Hello everyone. Today we're looking at 6.3a, which is graphing radical equations. So make sure you have the piece of paper that says day one. So what we're going to be doing today is graphing what's called square root. Those are those types of square roots functions. And we're also going to be looking at cube root functions. So we're going to be doing both of those today. Okay, so let's go ahead and let's get started. So square root functions. One of the things that we've talked about over the course of the semester is you can't take the square root of a negative number because it comes out with an imaginary solution. Well, the same thing is true here. We can't graph imaginary numbers. So when we come over here to make our table, and no, we're not going to fill it all up, we want to pick numbers that are going to not necessarily be negative, that are not going to be negative numbers, but numbers that aren't going to put a negative under our radical. We also want to select numbers that, if possible, are going to be perfect squares, because those are things that we know the square root of. So for example, 1's its own perfect square. We've got 4 and we've got 9. Now at this point, we're going to take each of those values and we're going to put it under our radical, and that will give us 0, 1, 2, and 3. Now, let's go make our graph. So going over here to the right, we're going to graph all of those points one at a time. And then we're going to draw our picture. Now notice in this case, I'm not going to put an arrow on this end of my graph. The reason for that is because it's not going to continue onward. It stops right there. It's a hard stop at 0, 0. And it's going to continue onward toward the right, slowly increasing as it goes. Now that's important because when we come over here to do our domain, we're going to put a hard bracket for 0. That's our lowest value on the table and our lowest value on the graph. And we're going to go up to infinity. Now when we do our range, that's our y values going upward. If you look at your y values, they also start with 0. And they will continue onward toward infinity to the right. Now, what's the shape of this thing? It looks like a sideways parabola. As long as we're here, let's go ahead and do our x and y intercepts. They're at 0, 0. We only have that one point where it touches the axes. Now let's talk about end behavior. So on the right-hand side, so as my x increases, my y is slowly increasing. It's continuing on upward. So we're going to say it goes to infinity. But on the left-hand side, there's no graph. So this is kind of an NA sort of a moment, not applicable. Now let's talk increasing and decreasing. Now remember, when you're doing these, you're only talking about x values. So my x values in this case, they're going to go from 0 all the way to infinity. And it actually is 0, so make sure you put a bracket on it. There is no spot where the graph is decreasing. So that is the parent function for most of the graphs we're going to be looking at today. Now let's talk transformation. So on this particular graph, I have transformed it. It's going to be moving left 3 and down 2. So again, you want to imagine that you've taken this graph and think about the 4 points that we graphed, and we're going to be shifting every one of them 3 to the left and down 2 spots. So now let's go make our table on this. And again, I want you to think about what's going to make a perfect square. So the first perfect square that we had in the table up above was 0, which is why I'm going to put in a -3 for my first x value. Because if I put a -3 there, I'll get a 0. The next number I had was a 1. So if I put in a -2, I'll get a 1. The next number I had was a 4. So I want to put in a +1. And the last number I had was a 9. So if I put in a 6, that will give me basically the same perfect squares under my radical. These produce -2, -1, 0, and 1. I get all of these values by putting these into the equation. Now, let's go graph. So I've got -3, -2, -2, -1, 0 and 1, and over here 5, 6, up 1. Hang on, I think I've got one in the wrong spot. Oh, yep, that one's in the wrong spot. Okay, so now let's go over. Oh, looks like I got 2 of them in the wrong spot. There we go. Fix those. All right, so now we got our nice graph looking like that. As you can see, each one of the points, especially that starting point, has been shifted left 3 and down 2. Now let's go over to our domain. So this time our lowest x value is not 0 anymore. My lowest x value is -3. And when I look at my lowest y value, it's -2. Now let's talk about x-intercepts and my y-intercepts. So x-intercept is pretty easy because that's actually a point that's on the table. It's 1, 0. Unfortunately, my y-intercept's not so nice. Now on this, I'm going to solve for the exact answer, but you are certainly welcome to solve for the value that would be not the exact answer, but a decimal, okay? So I'm just going to kind of pull over a little sheet of scratch paper here. So if I want a y-intercept, I just set this equal to 0. And we're going to be talking about this more in just a moment, but when you solve radical equations, which this is, you want to isolate the radical first before you square both sides. So I'm going to move the 2 to the other side. I'm now going to square both sides. So here's me squaring both sides. That's 4 equals x plus 3. Notice I didn't square what was under the radical because the square and the radical cancel each other out. All right, so let's see here. Let me make sure I got everything going okay on this one. So far looking pretty good. And then I'm just going to move this to the other side. Let me make sure I'm doing everything correctly. I'm thinking that, okay. Okay, minor mistake. It's the y-intercept, so I'm supposed to put in a 0 for the x. I was doing the other side. Hate it when I do that. Okay, so let's see here. That'll be y equals 0 plus 3 minus 2. So, that is a nasty one right there. Okay, so if you want to leave it as the decimal, that's perfectly fine. Or you can do what I'm about to do, which is put it into my calculator and get that decimal of -0.3. So if you'd like, you can certainly, take that approach. I'm going to write the exact answer. Be careful that your -2 doesn't look like it's under the radical. All right, so now let's talk end behavior on this little beauty. So my end behavior. So as we go to the right-hand side, we're going to infinity. As we go to the left-hand side, whoa, there's no graph. So that's an NA. And we are increasing the entire time we're doing this graph. So that is going to be -3 to infinity. And no decreasing. So that's what a square root looks like as a graph. Let's do a cube root next, okay? So let's get ready to do a cube root. All right, so if I want to do a cube root problem, of course I'm going to scoot on up here. Just a little quick reminder, because I know some of y'all sometimes forget, your square root button is right above your x squared, and your cube root buttons are right there. What do I mean by cube root? If you're wanting to use your calculator, you would hit 3, and then you'll push that x root button, and it'll do any kind of root you want. Okay, so that's an option for you. So again, if I'm doing a cube root, I put the 3, then I do the second and get into that root. Okay, so last time I wanted perfect squares under my radical. This time I want perfect cubes. Now, there aren't a lot of perfect cubes available, so I am just going to pick some nice ones that will come out there and actually graph. 0, 1, 8, and once I get past that, like bigger, it's not going to graph. Cube roots, you can also cube root a negative, so I'm going to put in -1 and -8 as well. Now, one at a time, I'm going to take each of those values and put them in. Now, let's go do some graphing. So I'm going to come over here. I'm going to do all my graphing. So I got 0, 0. I've got 1, 1. I've got over here 8, 2. So that half of the graph looks like this. And then I've got going the other way. That other graph. So notice this kind of has an S-curve sort of a shape to it. So when I look at the domain for this, this is all real numbers. When I look at the range, it's all real numbers. X-intercept, I've only got the 1. Now let's talk about our end behavior. Now our right side continues on toward infinity and our left side continues toward negative infinity. Now let's talk increasing or decreasing. As I move to the right, my Y values continue to go up and up and up, even if it's slow. So that'd be all real numbers, and I have no decreasing on this. So hopefully that one is okay. Let's flip to our next page. Now let's talk transformations, because we haven't done a transformation of a cube root yet. Yes, that is a cube root. So this one's got a lot of stuff happening. Under the radical, you're going to be going left 8. You're going to be going up 5. That negative on the front is going to cause a reflection. And that 2 is going to cause a vertical stretch. So that's what's going to happen with that. Let's go ahead and let's make our table. Now this one gets, we're starting to get a little bit trickier here as far as our values go. So let's start thinking here. I would like to have a 0 under here first, so that'll be a -8. Then I'd like to have a 1. That is a -7. Then I'd like to have an 8, so I would want to put in a 0. So I've got some positive values. Now let's talk some negative values. I'd really like to have a -1 there. That'll be a -9. And I might like to have a -8 happen in there. So that would make that a -16. Okay, let's go do a little fill in here. Now, this isn't going to fit on my graph, so I'm not actually going to end up graphing it. That's as far over as I'm going to go. But let's go make our picture. So go 8 to the left and 5 up. 7 to the left and 3 up. 0 to the left and 1 up. And let's see here, I'm going to have a -9 and a 7. Ooh, okay. Now this side is going to have this nice shape like this. And the other side is going to go over that way, kind of like off the edge of my paper. So just like with our other perfect cube, all real numbers. Just like with our range, all real numbers. Now let's talk about intercepts. Oh, that intercept is, that's not terrible for the y-intercept. But my x-intercept is going to be way over there somewhere, like off the side of my paper. So if I want to find the x-intercept, I can. All you have to do in order to actually find that x-intercept is set that equation equal to 0 and solve it. It does come out to be about 7.6, 0. And again, we'll spend some time solving these in just a moment. Now on my right hand side, I'm going toward negative infinity. Notice that this is going downward slowly, but it's going downward. And on my left hand side, I am slowly going upward. Now this function, unlike our others, it is decreasing the whole time. So I'm going to put a little decrease on that one, because if I come in from the left, I am going down slowly but steadily as I go down to the right or left. Now let's talk about writing some equations and kind of wrap our notes up. So there's two types of equations you are going to write. The first type that you would write would be for a cube root, and the other type would be for a square root. Let's start with our cube root first. Why? Because it's, well, example A. Here is your general equation for that. It's going to be a cube root x minus h plus k, and that plus k is outside of the radical, is not under the radical. Now, for the most part, our a is always going to be 1. So the biggest thing that we need to find is our h and k. So we need to figure out where this thing is kind of turning around. So I know that this is a little bit hard to read, but this point where it turns and kind of shifts from going one way to the other is going to be our 3, 4. And we are cube root shaped. So I'm going to come up here. This 3 will be my h and that 4 will be my k. So when I write my equation, I'm going to have the cube root of x minus 3. And then outside the radical, make sure this is outside, you're going to have a plus 4, and you're done. Yeah, that's kind of it. There's nothing else to it. Moving over to the right, we got square root. So here is your general formula for a square root. You will notice that this looks almost the same as the formula you just wrote, but that's a square root. You don't have to write the 2. What if you're aching to write the 2? I mean, I guess you can. All right, so taking a look at our problem, the first thing I want to do is I want to find where this starts. And this graph is a little bit easier to read just because the grid's copied better. It comes out to be -4, 3. Now, most of the time my a is +1, but as you can see, this does not go up to the right, it goes down. So I will have a -1. And then I'm going to have my x minus -4. Minus -4 makes a plus, and plus 3. And that is all there is to your notes for today. The remaining problems are your homework. They'll continue on to the next page, and then the one after. I want to remind you that with each of these, as you're going through these, I'm not sure I do every single one of them. The key is posted. But I want to make sure and do 2 square roots and 2 cube roots just to make sure you have the hang of it. These don't have to be perfect sketches. It just says sketch. It doesn't say that you have to like take out the graph paper if you don't want. And notice it's asking for domain, range, x-intercept, y-intercept. And that is all you're doing with those problems.